Today we're going to look at section 2.3, graphing linear functions. Our objectives are to be able to graph linear functions when in slope-intercept, standard, and point-slope form, and to be able to graph vertical and horizontal lines. So the equation of a line in slope-intercept form is y equals mx plus b. This is probably the one you're the most familiar with, where m is our slope of our line, our rise over run, and b is the y value of our y-intercept. Remember, y-intercepts are always written as points. So the b value goes to the y value. X and y are just our variables. Okay, and if I put x with its y, or input and output, that's just a point on the line. Okay, and those will fluctuate. There's an infinite number of points on our line. So what does a graph look like? Well, the first thing you should do is always try to graph the y-intercept. Okay, remember our y-intercept is just 0.04. So I'm going to go 0, up 4. The biggest mistake I see students make is they don't go to the y-axis, they go to the x-axis. So be careful with that. The next thing I'm going to do is look at my rise and run, -3/5. I always like to associate the negative with the numerator. So this means we're going to go down 3 units, right 5 units. So if I go down 3 and right 5, I get a point right there. Now you only need 2 points to graph a line, but to be a little bit more accurate, I like to put as many points as I can fit on the graph. So I'm going to go down 3 and right 5 again. And from here I'm going to go up 3, left 5, up 3, left 5. So when you go in the opposite direction, you just do the opposite movement. So what I'm going to do now is just connect those. Make sure you don't forget to connect them. Sorry about that. Try to do the best you can. It's a little bit harder on the computer. Those should go through each of those points. And make sure you put arrows on, because a line does go on forever. Just because we're only graphing a 10 by 10 grid doesn't mean that it stops right there. Okay. So standard form is ax plus by equals c. Again, x and y are our points on the line. Those are our variables. Okay, just point on line. And a, b, and c will be values that are given to you. We're going to be able to manipulate and use those values in order to get some extra information. So here's an example, 2x minus 4y equals 8. Now, some teachers talk about what we call the cover-up method. I don't like that term as much because it really doesn't give you any information about what we're doing. This method, when it's in standard form, we want to find the x and y intercepts. So we're going to find our x-intercept, okay, and we're going to find our y-intercept. Now the nice thing about an x-intercept is where the graph crosses the x-axis, and if the graph crosses the x-axis, I know my y value is 0. Likewise, if we look at a y-intercept, that means the graph crosses this y-axis, which means x is 0. And if I want to find a point, for here I know the output, so I can work backwards to find the input. So if I substitute a 0 in for the y, I'm going to get 2x equals 8. So that tells me x equals 4. So I get the point 4 comma 0. So I'm going to graph that. If I look at my y-intercept, I'm going to substitute in 0 for x. I'm going to get negative 4y. Again, don't forget to drop down the negative. So y is equal to negative 2. So now I get to point 0, negative 2. Let's make that red. Again, you only need 2 points to graph a line, but this isn't like the last example where I know what the slope is. But now that I have 2 points, I can count my rise and my run and use that to find more points. I'm going to start at this one. Doesn't matter which one you start at. I like to start at the lower one. I go up or rise 2. I run or go right 4. So if I go up 2, right 4. Down 2, left 4. Down 2, left 4. And then I can connect the points. And try to do a better job than last time. And there's my line. The last one is point slope form. I think this is one of the best forms to use. It's the most useful most of the time, it's just when we get to harder problems, but you might not have seen this before. So point slope form, again, has this m, which you're used to, which is our slope, our rise over run. But now it has two types of y's and two types of x's. The x and the y are our variables. Okay, again, those are just points on the line. Okay. But the x1 and the y1 are given to us. Okay. Okay, again, it's another point on the line, but it's a specific point on the line that they're going to give us. Okay. So let's see how this looks. Y plus 6 equals negative 2x minus 1. Okay. So I know my slope is negative 2, but I like to write that as a fraction so I know my rise or my fall and my run, positive 1 to the right. But I can't do this unless I have a point to start at. So how do I have a starting point? Well, this 6 and this 1 are going to come into play, but let's go back for a second. Okay, if we go back, you notice these are, sorry, that should be a minus sign right there. We have a minus sign and a minus sign. Okay, both of these should be negative. So when I come here, I notice that this isn't a negative, it's a positive. So I have y minus negative 6 equals negative 2 times x minus 1. The reason why we want these minus signs is because the x1 and the y1 are after the negative signs, or minus signs. So that means that my x1 is a positive 1 and my y1 is a negative 6. So if you kind of think about it, if we look up here, x, it said x minus 1, but I put down a positive 1. This said y plus 6, I put down a negative 6. You're always going to get that kind of reversal of our signs because we want what's after the negative. So now that I have a point at 1, negative 6, and a slope of down 2, right 1, I have 2 points for my line. But I'm going to continue them. Down 2, right 1, up 2, left 1, 2, left 1. I'm going to do this all the way across just to give me a more accurate line. Okay, so I'm going to use red. And then I'm going to connect my points. And that's how you do point slope form. So what does the equation of a vertical line look like? It's always going to be x equals some number. So x equals 5, x equals 0, x equals negative 1/2. It doesn't matter what it is. It's always going to be x equals a number. Now, you might think, how do I know the difference between x equals 5, a solution x equals 5, a number? Well, it's going to depend on the context, and you'll have to read the problem to see, are they talking about a line or are they just talking about a solution? Okay, and our graph of our horizontal line is always y equal a number. So y equals 9, y equals negative 3, y equals the square root of 2. It doesn't matter what it is. That's how a horizontal line looks. So let's try to graph one. Okay. X equals 7. What does that mean? That means the line where every single x value on that line has a value of 7. So let's think about points that have a value of 7. 7, 0, 7, 2, 7, negative 1. All of those are points on a line where x equals 7. So let's think 7, 0, 7, 2, 7, negative 1. Okay, that's why we get a vertical line at x equals 7. Okay, every single point in this line will have a value of x that's equal to 7. If we come over here and they tell us y equals negative 3, and I know I'm graphing a line, that means that the y is always negative 3. So I can do 0, negative 3, 5, negative 3, 10, negative 3. So now I'm going to graph it 0, negative 3, 5, negative 3, 10, negative 3. And that might help you have some points. So now you can draw your horizontal line where every single point on this line has a y value of negative 3. So I'm going to look at this last one. This is our parent function. This is our most simple equation of a line, y equals x. And for some reason, this gives students a lot of trouble when we ask you to graph this. And I think it's because it's so simple, it makes it hard. So let's think about this equation in our three different forms. In slope-intercept form, we'd have y equals, our slope would be 1, x, and then plus our b would be 0. Okay. In standard form, our x's and our y's have to be on the same side. So I'm just going to move the y over. So I'm going to have, let's say, x minus y equals 0. Okay, if I subtract y from both sides, I'm left with 0. And again, it doesn't matter what side I write my equation. It doesn't matter if I write the 0 on the left or the right. And then in point slope. All right, well, I already know the slope of the line is 1. Okay. But now I got to think about my point. What's a point on this line? Well, what am I adding and subtracting to x and y? Well, I'm adding and subtracting 0. So minus 0. Oops, sorry, let's make that an x. And 0. Okay, so let me show you how all three of these work. Y equals 1x plus 0. This is one you're probably most used to. It has a y-intercept of 0 and a slope of up 1 over 1. Up 1 over 1, up 1 over 1. Okay, I'm going to do this in both directions. So I'm going to get our parent graph, our most simple equation of a line, runs right through the diagonal. In standard form, let's show how this works the same way. If I want to find my x and y intercept, okay, for my x-intercept, I'm going to substitute in a 0 for y. If I substitute a 0 for y, I get x equals 0. Okay, if I want to find my y-intercept, I'm going to put 0 in for x. If I substitute 0 in for x, I'm going to get negative y equals 0, which means y equals 0. And that is true. My x-intercept and my y-intercept were right here at 0. Point slope, okay, I can write point slope in an infinite number of different ways because the point 0, 0 is on my graph. But so is the point, let's say 5, 5. So I could have written y minus 5 equals 1, x minus 5. That would have worked as well. The point negative 4 and negative 4 is on the graph right here. So I could have written y minus a negative 4 equals 1, x minus a negative 4. But we usually wouldn't have written it this way. We would have written is y plus 4 equals 1, x plus 4. Okay, so every single line that you guys graph, you can come up with the different forms and figure out how to write those equations, which we'll spend a little bit more time in our next section. So if you feel a little bit better about the basics of graphing linear functions in slope-intercept, standard, and point-slope form, and you're able to graph vertical and horizontal lines.